Internet. All right, so today we're going to start chapter 6, but before we get to that point, let's go back to the content page. Last week we did branches, participation labs. You did your technical interview thing for discussion post, right? They're not technically due till midnight tonight because I changed the due dates. So any last minute pressing questions, now it's time to throw them at me. I see a whole bunch of nothing coming. Okay, so if you do have a pressing question and you want to grab me right after class because you don't want to do it the whole class, feel free. I do have to run fairly quickly, so I usually stop 15 minutes early, so catch me then and then. But I do have to be out of here by 5. So, just saying. That's usually not a problem because you guys are usually long gone by then. Anyway, so chapter 6 is all about loops. I have a PowerPoint presentation I'm going to do today to show you what loops are. We're going to talk about 2 different types of loops. And one of those loops has 2 different types inside it, but we're going to talk about loops. Loops are going to make your life so much easier because every time you need to repeat something, you can use a loop, and life is fun with loops. We're going to do the PowerPoint today. We're going to talk a little bit about it, introduce your terminology, going to show it to you. Thursday, I'm going to actually do code with you, and we're going to play with turtles and draw little things on the screen, which is great because it starts introducing you to turtles, which in 2 weeks is your project 2, has a big thing with turtles. So I'm baby stepping you into the next big project. We also have got to schedule in a test. It happens. We had a test over chapter 1 through 1 and 2. We've done 3, 4, 5, and now we're on 6. Do you really want me to keep covering material before I give you another test, or do you want me to test you?
You were tests.
There's only 4. Okay, I'm not arguing with you about how many tests. We're not arguing about how many tests yet.
Classes I'm comparing this to test you.
Go ahead and close that door in the back, please. So we're gonna start talking about it. We're not having it this week, but don't be surprised if next week there's a test that shows up. Just foreshadowing your future. I wrote it today. I haven't got it up on the transferred into course yet, so it's coming. Just foreshadowing your future. I'm gonna try not to screw up and have any that are misformatted this time. If you guys take a test with me again, and the code is all printed in like one long line vertically, there's something wrong with that question. Please mark it and send me an email because that was not what it was supposed to be. That was an import failure where I imported it from one program into another. That being said, those of you that actually read that question and got it correct, kudos. I don't know how you did that, but
Well, that wasn't wrong.
hey, kudos for putting the effort into figuring that out. So we are going to talk about conditionals today. I went ahead and put this week's assignments out because I realized they weren't visible to you guys. Sorry, I thought I had already had them visible, but they're visible now. I also went ahead and did chapter 7 just to get them out there in case somebody wants to get ahead, because some of my online students do like to journey on past me. Not many, just a couple. But they're both out there. And then the week after that, we're going to do a project. No new material during project week. I was kind of hoping that the test would fall that week, but it didn't. Yeah.
I was asking, are you foreshadowing the test before or after the?
It'll be a week before for the project, yeah. We'll make it work, promise. And then there's another week and we have spring break. Would have been nice if spring break had been like a week earlier. But it didn't work out that way in our class schedule. That being said, we are going to move all the due dates to Tuesday. I may not make the project due until the Friday before spring break, just to give you a few extra days. But I still need to cover new material. So, let's be honest, I'm probably not going to grade it until spring break when I have some free time. So anyway, the project you may get 10 days to do it. I'm sure you all are going to be really disappointed about that.
So,
I'm sure it breaks your heart. All right. That being said, let's get started on our PowerPoint for today. Where did it go? There's that tab. I posted the PowerPoint on Coursed, so if you want to go back and look at it, you can. If you find any mistakes in it, just ignore those. We all know I can't type. So we're going to start off talking about while loops first, then we're going to move into for loops. As you go through the chapter, again, it's going to be one of those things where they do a lot of extra stuff in the chapter that is important, but I may not verbally say out loud in class. Doesn't make it unimportant. It just means that I try to concentrate on the big picture. I want to remind you that we've already done the random modules. We've done some random numbers before. We talked about it, right? It's going to come back into play when we start doing the project 2 and when we're playing with turtles. So I just want this slide is just a reminder that random's out there. A little and more foreshadowing in your future. So far we've done control structures. We've done some function calls. That's those things like print, string length, things like that. We've done some function calls. We're going to do loops. We've already done conditionals, if and else's. So we're adding to our control structures. After this chapter, we're going to have a whole section on how to write your own functions. Normally, when I teach this class, I usually actually introduce that before I do loops and ifs. So after I do it next week, I'll let you know which I like better. Anyway, so we're going to do that. We have 2 types of loops. We have a conditional loop and we have a counting loop. Conditional loops are while loops. They're going to do something while the condition is true. So there's not a set number of times it's going to do it. It's just going to keep going until it's not true. So it's like when you're playing a video game, until you say quit, it keeps playing. That, in its simplest form, is a while loop. While something's true, and you actually can put the word, have a variable in there that is true or false. While play is true, it's going to keep going. One of the conditions inside the while loop is to set it to false. Once it gets set to false, it quits. So that's a while loop in the briefest form. A for loop is more for something like you have a set number of times something has to happen. You may not know what that number of times is because the user is going to input a variable number or something, but it's going to count by 1 or by some increment. And it's going to do it until the boundary is met. So add 1 to total until I is 10. The index is 10. So for 0 through 9, it adds 1 every time. But as soon as the index of what we're checking is 10, it stops. So it's counting up to a set point. Make some really bad examples of while loops. you're gonna keep eating until you're not hungry. While hungry, eat. I wish my brain actually shut off at that point, but it doesn't. Also, if you think about your radios, well, I don't know how many of you use actual radio stations and not use satellite radio or your phones at this point. But if you're in your parents' car and your mother's pressing the scan button, you're gonna keep scanning until she finds something she enjoys. So while you don't like the current radio station, you keep scanning. You can tell I'm in a different generation than you guys. All right. So, like I said, if you like the radio station, you stop. If you don't, you continue on. I'm also a cheapskate, so I won't pay for something I get for free over the radio. Streaming services. So you can look something like this in code if you had a function that's called light radio station that takes a state radio station. If that function evaluates whether or not you like it, can you actually write code to do this? No, because how is the code going to know whether or not you like it? You can ask for user input, but you know, so not my greatest example, but you could have something like this, where you're telling your turtle that you want him to move forward and then turn 90 and then move forward and then turn 90 and then move forward and then turn 90. But you could condense those lines of code into a for loop. For I stands for index, shortcut universally used in just about every language I've ever programmed in. For I in range 4. I need it to go 4 times. While I is not greater than 4, I'm going to do this set of code. So in this case, I could take 8 lines of code and condense it down into 3 lines of code because 2 of those lines are repeated 4 times. Does that make sense? Yes. It repeats both of them because indentations work. Everything that is indented, say that fast 3 times. Everything that is indented under the 4 happens every time the for loop runs. This is where you need to be really careful with your indentations, because if you unindent a line that should be in the 4, it doesn't run but 1 time after the for loop. Or if you put an extra line into the 4 that you didn't mean to be there, it will run multiple times, right? And then you're going, why did I do that? And then I go over, oh, you need to either indent or unindent X number 1. So when you start doing the zybook stuff, if you're getting too many lines of output, your loop either ran too many times or you have something in the loop that shouldn't be, right? Or if it didn't repeat something that you intended for it to repeat, then you might not have indented it correctly. I'm trying to cover all those quirky zybook errors before they come up. So a while loop starts off with the keyword while and then a condition. So just like your if. So you put something in there that evaluates to true or false. That makes sense? 5 is less than 10. That's true. If it's true, the indented statements run. If it's false, it skips all the indented statements and goes to the next unindented line. This is a simple while loop. Now, while loops need to have all of their variables set up before the loop happens, because if you create a variable and give it an initial value inside the loop, every time the loop runs, it resets itself. So be careful of that. So we're going to set up a variable called loop and put it at 0. We're going to set up a variable called sum and let it start at 0. While loop is less than 5, we're going to add 2 to sum and 1 to loop. Does that make sense? When we're done with our loop, when it's finished running, see how print's not indented, then we're going to print out whatever's in sum. So in this case, because it starts at 0, how many times is this loop going to run? What? No.
4 times. 0 plus 2.
Try again.
Right.
It's going to run 5 times, right? So to run for 0, 1, 2, 3, and 4. So that's 5 times. You have to remember, computers start at 0 unless they're told otherwise. This one didn't. It's told it to start at 0. Be careful, because if you forget about that 0, sometimes it runs 1 too many times or 1 too few times, depending on what you're doing, whether you're going up or down. That's called an off by 1 error. You'll often hear people come up and, debugging your code or talking about code, the off by 1 error. It's caused by this thing that we do in computer science where we start counting at 0. It also can take place if you do less than or equal to when you meant less than. Because if this was less than or equal to 5, it actually runs 6 times. So be careful with signs, greater than, less than sign, and the greater than, equal to, those things. And also be careful with the off by 1. For loops are a little bit different. We don't have to set up a variable for our counter like we did with the one before. Loop was our counter variable, because we can do that inside of the for loop. The I is part of the syntax, and by doing a for loop, you automatically have created a variable called I. I is going to automatically start at 0 unless you declare I above it and give it a different starting point. Up to you. But if you just remember it starts at 0, you can make your range accordingly. This is a little bit different than, say, Java, because in Java, you would have some sort of conditional statement in there instead of the word in range. So in range will be typed for this type of for loop. There's more than one type of for loop. And then inside the parentheses, you put the stopping point. Right? That's what you're testing for. So in this case, for I in range of 5 means we want it to run 5 times, right? And it does the same thing as the last loop. It totals up those numbers and prints it out. Why do I have 2 different types of loops? Because they do slightly different things. Can they be interchanged in places? Yes, but flexibility, speed, not forgetting where your variables are, whatever works with you. I prefer for loops if I can use either one, because I'm bad about forgetting to initialize that counting variable. The for loop does it in the same line with the for. I don't have to. Same with Java for me. So turtles are going to be something that's going to be part of your life moving forward. Thursday, we're going to introduce them and play with them. We're going to draw things. You're all going to go, why are we doing this? And the proof point. So we're going to talk about turtles. Turtles have to have a screen to draw in. So there's a lot of import statements that we're going to use, which is why we had to do the module section before we got here. So we're going to import turtle. turtle knows that it has to draw itself in a screen. So there's some screen commands. It knows whether or not it's in a screen or not, or if it's touched the edges or if it ran off the edges. We usually, in my case, I usually name whatever screen I build window just because we make a little window. So what this one does is while the turtle is inside of its window, this loop's going to keep going. So what that basically is testing for is that we don't drive our turtle, our car, whatever we make our sprite at this particular point off the screen. Because if you don't pay attention to that, the computer will let you move your turtle off into an imaginary space. So this one is a while loop with an if inside of it. So we have nested another control structure inside of our while loop. So while the turtle is in the screen, we want to randomly flip a coin and get heads or tails, 1 or 2. If it's 0, we want our turtle to turn left. Otherwise, we want it to turn right. So we're randomly having our turtle turn right or left and then move. So we don't know where the turtle's going to go. And the turtle's going to keep running until he touches the side of the screen. Now, this sounds like a lot, and it's really confusing. But the great thing is we're going to do this in lab on Thursday. I'm going to stand up here and demonstrate how to write the code for this. We're going to start a little bit simpler. I'm also going to demonstrate how to write the code to create a square first and put that into a loop. But ultimately, we're going to keep going until we write a cute little program that makes our turtle randomly draw screen. Questions so far? Loops are not really hard, but they add functionality to your code. They can be confusing. So definitely ask questions. And I am not expecting you to get it on the first try because it's new. So you do have to also pay attention to what we call an infinite loop. If there's no way for the loop to ever stop, it's called an infinite loop. Y'all you probably all have seen the blue screen of death, or at least heard jokes about the blue screen of death in Windows computers. Infinite loops will ultimately cause a blue screen of death in most computers if you let it run long enough. You'll eventually run out of memory, and you'll get a memory error. This takes forever in modern computers. Back in the day, back in our day, you could actually crash a computer with an infinite loop from one of our assignments. I have crashed an entire mainframe before, but let's not talk about that. This one, if you look at it as this, can anyone see why this loop doesn't stop? Because the variable loop is never changed. So it's always 0. So 0 is always going to be less than 5. So you'll be sitting there and you'll go, why is this taking forever? And ultimately, you'll reach up and click the X on idle or whatever you're doing because you're like, that's weird. But you have an infinite loop. It's going to run until it runs out of memory or you get tired of waiting on it and kill the process. It happens. To me, it's easier for it to happen in a while loop than a for loop. But you can make it happen in a for loop by improperly changing I inside of the loop. But most of the time it happens in a for loop. while loops. Why the two? Like I said, there's various reasons for it. While loops are used more for those situations that you're waiting for a user to tell it to stop, or you're waiting for something that you don't know is going to happen, some event to happen to make it stop. For loops are better for specific numbers. Honestly, the two examples we just did was a loop. We knew we wanted to only go until 5. That really is a better use for a for loop than a while loop. They infinite loops are a possibility for both. They tend to pop up more frequently for the while loop, in my experience, but you can do it both. So one reason a while loop is used is for validating input. So you would use a while loop around input statements, and you would have that while loop run until they give you the correct input. So like if you had an input statement asking, you probably all have done this on a website, they ask you for your phone number, but sometimes they want it with dashes, sometimes they want it without dashes. If it keeps coming up with an error message, that's a while loop because it's waiting for you to put it in the correct format. Once it sees that format, it flips the loop variable to false. So it stops running. Make sense? So it's used a lot, while loops are used a lot for verification of data or input, or verification that you intend to keep playing. We are also, I have a little thing we can do where you have to put your own game together. I may get y'all to do that too. I may throw some of the Zybook labs out and do some of my fun labs too. I know they're assigned right now, and if they are, I will cancel them. But if you'd rather do some of my labs, we'll do those this time. Show of hands, who'd rather do my labs than Zybooks? It's about 50-50 split. Huh? You don't care one way or the other. So I may lighten up the Zybook stuff some and just throw some of my labs at you. A little more grading for me, but it's okay. They're more fun. Have a guessing game number. So this one is something you'd see for like maybe validating. We see here we've created a variable called loop. Have a variable called loop. We set it equal to true. So far we haven't done variables set equal to true or false, but you absolutely can set them to the value true and false. In Python, true and false start with capital letters. And remember, I told you only special cases are capital letters. That's because these are special cases. Right? We don't want them to be considered variables or strings. We want them to be the value true or false. They should, unless I'm sadly mistaken, show up as a different color in idle. Let me verify that before I tell you wrong. Because, it happens. See how true is orange and while is orange and if is orange? Because those are parts of the language that are important constructs, right? So if you type in true and it doesn't turn to orange, you've done something wrong if you're trying to make it a Boolean variable or a Boolean value, I guess. Does that make sense? So it really doesn't like it when my slides are copied and pasted. If I did something like this, And idle, I've got orange colors, I've got purple colors, I've got green colors, and I have the regular black text. Because they're all different key parts. And that helps us as coders quickly identify what we've done. So if we have loop set equal to true, then we can put loop into our while statement. Doesn't need a condition, doesn't need to be compared to anything. It's just going to evaluate that variable. That variable is holding true. So this is always true, right? Then we put an if statement inside of our loop. If value is greater than or equal to 0, because we're trying to get them to enter a number, a positive number, then we set loop equal to false. Otherwise, we print invalid number. Please try again. Please input a positive number. And then this loop goes up and it runs the input a number query again, changes it to a, and it does the if statement again. If on the first try they gave me a positive number, you never see the error message because it doesn't get to the else part of the if. Loop becomes false, and then while false never runs. Everybody with me? Anybody confused? Okay. I'm not running this right now because it does. Well, I guess I could. I think it'll run. Let's see. Oops. Yeah, that's what I'm afraid of. It doesn't like the PowerPoint tabs. So let's see if it run now. You win. I hate PowerPoint. Okay, what it is so I put in -5, it's asking me again, right? I put in 5, I should be fine, right? The reason the copy and paste doesn't work is the PowerPoint and Word has extra formatting behind the scenes that Microsoft has built into their products. So it doesn't, it's not a typical tab or a typical quotation mark. It's special. It's tab ++ or something. I don't know. Anyway, that is an example of a while loop that is checking values. Now, we can use this for menu structures too. If 1 is pressed, do this. If 2 is pressed, do that. Like your phone calls, press 1 to reach account payable. Press 2 to talk to a service manager. Press 0 to exit this call. So each one of those things has a different thing. The 0 option is the one that turns the loop variable to false to stop the process from going. Now, granted, on a phone call, you have a different option of just hanging the phone up, but that's something else. So, back to my slides. Sentinel values are what that 0 is. A lot of times you'll have sentinel values that are unreachable, like -999 is a sentinel value that a lot of things use that are taking numbers. Because if you only have like 5 or 6 choices in your menu structure and somebody types in -999, they obviously did that with intent. You would hope. But that's not something you just accidentally type. So that could be your value to shut it down. It's something that we use a lot as programmers while we're testing. It gives us a value to stop the process midstream because we're testing it. So you'll see a lot of times that the Sentinel value is at 9 for quit, 0 for hang up. Those are Sentinel values because they're not in the sequence of normal values that you were expecting. So in this case, it's written with a Sentinel value in. If value is equal to -999, turn it false, we're done. Otherwise, we want to keep adding. So this one's going to ask you for numbers. It's going to keep summing up into a total for you until you give it -999. Now, what if you wanted to subtract 999? Well, this is not the right loop for you. Not going to work. So you need to make sure your Sentinel value is something that should never be inputted except to stop the program. So in our first case, we only wanted positive numbers. So if we made them only put in positive numbers, and then we have a negative number for Sentinel value, I guess that is reasonable. Questions? Am I boring you all to death? I can't see faces. The computer monitors are in front of most people's faces. So. Thumbs up if you're with me. Thumbs down if you're not.
Sideways.
Sideways if you think you're getting there, you want me to keep talking. Or a couple of you can just ignore me. Okay, good to know. I can talk all day. If you haven't figured it out yet, I will talk all day and not care at all. I am your atypical computer geek. I am an extrovert, not an introvert. Why teaching is my forte. I love it. So we are going to do an example as we move forward of a guessing game. Are we going to do it right now? No. Am I going to set you up for it? Yes. So Thursday, I want to introduce turtles and have you start playing with them. And then we also, if we have time, we'll start playing with this guessing game example. But honestly, between now and Thursday, I may go remove a lab and just give you the guessing game as a project, mini project to do on your own. But we'll get it started Thursday and Friday, or maybe I'll just save it for next week when we do functions. Oh. I don't want to derail my online students. So it may be something we just videotape us all doing together, but we'll see. All right, but if you think about this in your head, we're just going to think of the logic here for a minute. If we wanted to ask our user to guess a randomly generated number, remember I said random was coming back, right? We could get this started. We can have our while loop run until the number's guessed, or a Sentinel value is put in, because they may give up and not want to guess anymore, right? So we have a loop that's going to run, asking them to enter a guess, and then inside that loop, we're going to have an if statement. Is the number equal to, is your guess equal to the number? If it is, hey, hurrah, you win. If it's not, we need to run again. Unless the Sentinel value has been put in. So we have like 3 conditions in our if. Is it equal to? Is it the Sentinel value? Or everything else? Now, this can get really hairy if I keep adding conditions to my game. I might want to know if it was greater than or less than the number, things like that. But simply put, it could be done with an if statement that has 3 branches and a while loop. Now you could be guessing forever. So it's guessing a random number between 0 and 100. You theoretically could have to guess 100 times. And if you're not real good at keeping up with what you've already guessed, you might repeat yourself. So that being said, it's not as simple as it thinks. But moving forward, we're going to start putting this together a little bit. We're going to start playing with turtles and getting you the visual for those. When we do functions, we're going to write functions for our turtles. And then we're going to do our project with it. But I wanted you to see the guessing game idea because I want you to see how loops and if statements work together. And that they're not individual items that never interact with each other. All right, that's all the new material I have for today. Like I said, we're going to do some labs Thursday. Does anybody have any questions before I cut you loose? All right, well, that's it for today then. I will stick around if anybody has any questions about stuff due on Tuesday.